Hello and welcome back to this course on fundamentals of data science. We are right now dealing with various aspects of a statistical model, and we talked about the explanatory data analysis. And today in this class we are going to discuss about missing values, basically missing data, and we are going to see how we can handle those missing data. And along with this missing data, we are going to see about outliers, and we are going to see how we can work with those outliers. That is the contents for today's discussion. And in our objective for today's class is missing values and its importance. Why missing data is important for us? Why do we have to care about it? And we are going to deal with different types or methods how we can handle those missing data. Then comes about the outliers and its significance, why it is important, and ways to handle the outliers. These are some of the topics of today's discussion. Basically, we are going to focus on missing data and the outliers. What is missing value or missing data? A missing value or missing data occurs when no data values is stored for a particular variable in an observation. So missing data is a common occurrence and can have significant effect on the conclusion that can be drawn from the data. Of course, you might have come across such missing data in your lifetime somewhere. You might have been looking for particular data, maybe something is missing, and this may be because of various reasons. Maybe sometimes this occurs because there is no response from a person with whom you are asking about a survey, for example. No information is provided for one or more items from a particular person, for example. Some items are most likely to generate non-response than others. For example, if you ask about private things to someone, maybe probably they will not answer that question. Yes, people at times tend to not reveal certain data, which means that we are losing that data. So at times we might have encountered the same thing. When you are asked to provide some data, you are a bit reluctant. For example, when people asked about simple questions, whether they would like to provide the data about their car parking within the city, almost more than 50% of the respondent, they said they would not like to share. Actually, the city authority is asking for that data just to improve facilities for parking, to find a parking lot for all the cars, and to suggest the place where there is a parking lot for a new car that is coming in. In that case, anyway, every citizen has to provide information about his car's location as well as where his car is currently parked. But some of them, they hesitate, they don't like to participate. Well, which means that without everybody's information, it's very hard to provide a solution to this problem of parking lots. Yes, missingness or missing data occurs when participants drop out before the actual survey is taken. That's one of the reasons, but there are several other reasons. We will see one by one. And when it comes to the data, again, our data might be missed sometimes while we collect the data. Maybe you have a census from which you are collecting the data, and if the equipment is faulty, probably it might not collect the data. At times the equipments are just faulty for a minute and it loses the data, and it will not collect that particular informations. Yes, there are, simply speaking, missing data can occur anytime, anywhere, for any data, with various reasons. It may be a fault of an equipment, or it may be other reasons, like even at times human error. If humans are inputting the informations, humans are prone to error, and it is likely that we miss some information. So there are three main problems that missing data causes. Missing data can introduce a substantial amount of bias, make the handling of analysis of data more difficult, and create reductions in efficiency. So can you see that? Missing data can cause bias. It can, of course, add difficulty or complexity to your system if some data are missing, and your overall efficiency is reduced, which means that this problem of missing data is vital. Let's look at more information on how this can be handled. Sometimes some data are missing completely at a random. Some data are missing at random and missing not at random. So we will see what is what. Missing data can be handled based on various informations. Let's look at one at a time. Missing completely at random. In other words, we can abbreviate this one, missing completely at random, MCAR. If events that lead to any particular data item being missing or independent both of observable variables and unobserved parameters of interest and occurs entirely at random, then we call that as missing completely at random. So when the data are MCAR, the analysis performed on the data is unbiased. However, the data are rarely, very rarely, MCAR. So when this happens, the missing data is unrelated to any study variables. Thus, the participant with completely observed data, or in effect a random sample of all participants, assigned a particular intervention. So this is one way of missing the information. Sometimes when you have data missed, the random assignment of treatment is assumed to be preserved, but that's usually an unrealistic assumptions. So this can happen, missing completely at random, if an event that leads to a particular data item being missed or independent both of observed variable and of unobserved parameters of interest. The second part is missing at random. So this occurs when missing is not random, but where missing can be fully accounted for by variables where there is complete information. So it is happening randomly. Since missing at random is an assumption that is impossible to verify statistically. Let's consider this example. So an example is that the males are less likely to fill in a depression survey, but this has nothing to do with their level of depression. After accounting for maleness, depending on the analysis methods, these data can still induce parameter bias in analysis due to the contingent emptiness of cells. For example, you are a male respondent, and if you have depression, you are most likely, it seems that they don't give in the information. They don't fill in that information that they have a depression. However, if the parameter is estimated with full information, this missing at random will provide asymptotical unbiased estimates. Just like sometimes you are at the airport and you have to come out of the airport, and before you come out of the airport, some authorities are asking you to provide certain medical information. Do you have certain symptoms? Yes, we have to be honest with that authorities, but sometimes some people feel that they have to go out and they have to go home, so they just tend to say that I don't have any symptoms. That is not the good way, but when this happens, that's where we are missing at random, and in fact that can create a huge problem. As you can see, if this happens to some person somewhere in some airport in some country, probably there is a huge chance that that person carries maybe a carrier, we are not sure, if he has a symptom. Missing not at random, MNAR. So it's also called as non-ignorable or non-responses. Is the data that is neither missing at random nor MCAR, the values we have seen before. So to extend the previous examples, let's see, it would occur if a man failed to fill a depression survey because of their level of depression. So that can happen, like so you see it here. So here we talked about that males are less likely to fill in the depression survey, but this has nothing to do with their level of depression. Yeah, they are nothing to do with the level of depression, just because they are not filling out the information. Likewise, as we can see here, this is another example we can notice with respect to either you can talk about the depression survey, or here we have another example here. We can see the completed data of age and IQ score is given, and there is another other side we have an incomplete data of age and IQ score. So when data are missing on IQ, and only the people with low IQ values have missing observation for this variable. A problem with this missing not at random mechanism is that it is impossible to verify the score or missing not at random without knowing the missing values. So just like we have seen here, so these values are missing, and you can see that these values, the people with low IQ, they don't like to share their information. That is similar with what we have seen in the past. Sometimes people tend to ignore things, or just they don't respond to certain informations, but these are vital informations if you want to make decisions based on those data. Missing data, we can see some examples here. We already seen 3 different types of missing data, and if you look at the graph, this graph shows the probability distribution of estimation of expected intensity of depression in the population. So that's the curve, different curves you can see. The full data set is available. The first black curve shows us the full data set. So the number of cases is 60. That's the number of cases we had. Let the true population be standardized normal distribution. So we are going to term it as normal distribution, and the non-response probability of logistic function of intensity of depression. So basically conclusion that we make here is that the more data is missing, this MNAR, the more bias are the estimators. For example, here the first one is the full data, and the second information that we have here is 25% of the data are missing, and missing not at random. Here 50% of the data are missing not at random, and here 75% of the data are missing but not at random. So these are different ways to express the missing information, but as you can see the trend changes drastically, which means that whenever you have a missing data, there is a huge bias in your results. Just imagine even this one here. With these missing data, if you want to make decisions, how would you end up with? Suppose you want to calculate, even just calculating mean or standard deviation or variance, you would end up with the very wrong values. So what are we going to do then? We have few techniques to handle missing data, and missing data itself is a huge research, and if you want to perform some projects or if you want to work on that, you can study more on this missing data. And today in our lecture we are going to see some methods that possibly people can use to deal with missing data. The one popular way is the imputation, where values are filled in the place of missing data. You can try to fill in the values, try to see what would be the right value to be filling in. So of course you should know the domain well in order to fill such information, or you can omission, where sample with invalid data are discarded from further analysis. And finally analysis, by directly applying methods unaffected by missing values, just ignoring the missing value and try to proceed with it. And people also use some examples like interpolation methods. You got two values, and with these two values they try to interpolate the middle value. And some people do partial deletion, that is also possible. Let's look at few information about these imputation, omission and analysis. Imputation. In statistics, the imputation is a process of replacing missing data with substituted values. So when you substitute a value point, in other words when substituting a data point, it is known as unit imputation. When substituting for a component of a data point, it is known as item imputation. Basically you are going to replace or substitute a value for the missing data. Once you have all missing values imputed, the data set can then be easily analyzed using standard technique, because you have the complete data right now after performing the imputation. So here is some examples. For example, here you can see January, February, March, April, and this May is missing, so you have inserted May. And moreover, some information is missing over here, so you replace with 0. And here you are replacing with the previously known value, and here you are replacing with mean, and here you are going to interpolate and you are going to use the answer. So which means that unless you know the domain well, you don't know exactly how you are going to replace it. For instance, it is not always best to put 0. In some cases zeros are fine because you know the domain, so at that time if there is an empty space you can put 0. If data is missing, you can put 0. But on other occasion, as you can see here, so they have replaced with the last known value 129 here, or they replace with mean value. Now, these are different approaches we can use to treat the missing values. And still more, there are a lot more other methods available. I am not sharing at this moment. Maybe you can have a look at other informations about missing values, how to treat and replace the missing values. These are some of the typical methods. Matrix completion. If you talk about the collaborative filtering, or if you talk about the recommendation system, we try to fill in the gaps in a matrix. Just like we can see here, Bob, Alice, Joe and Sam, they have their ratings for different movies, and based on that we are trying to fill in the empty space in the matrix completion process. So anyway, I am not going to deal fully with this right now. We can discuss about it more detail when we talk about the recommendation system and the collaborative filtering. At that time we will see how we can do it. We can establish certain relationship between individuals, and based on that you can eventually fill in the information. So in this case we have come up with this 2 place where we are filling out the information. Based on some relationship, we are trying to fill in the information. So likewise you can fill in the whole matrix. In fact, it's kind of a missing value being filled in. Coming to outliers. Again, in statistics, an outlier is a data point that differs significantly from other observation. So it should be significantly different. Did you see here? So almost all the temperature values are around 70 degrees Fahrenheit, but this one is 300 degree Fahrenheit. So if you take the mean of this value, it will be little bit more than, say, more than 75 or 76, or in fact more than 80. In fact, it will be more than 80 if you take the average or mean, but if you take the median, the middle value, it will be around 70. Before that, if you just try to arrange in the ascending order, say for example in this case you have 69, 69, 70, 70, 70. '71, '71, '71, then you have 72, 73 and 300, right. So if you try to figure out these values, so you will be seeing how you can take the middle value easily, right, and that really represents the true median values. It can give us the central tendencies, but this one 300 is an outlier. And that's an odd one out from this observation. So here is another example of this outlier. Basically, when you see this outliers, for example, if one calculates an average temperature of 10 subjects in a room and 9 of them are between 20 and 25 degrees Celsius, but there is one with 175 degrees Celsius and the median value between 20 and 25, if you take the median value, it will be between this 20 and 25, but if you take mean value, it will be around 35.5 to 40. So you can see the change that is happening. So it's always better to have a median that can reflect the temperature better at random samples, unlike the mean value. So we should be careful with mean and median. Median can represent a better central tendencies than mean values. So methods for identifying outliers. So if you use the box plot, you might be already familiar with the box plot. The center shows you the median values, and the 75 percentile or 25 percentile, and the outliers are already shown here. It's easily observable. So you can see the upper fence and the lower fence, and here is the maximum observation given here, minimum observation is given here. So if you try to display all your data using this box plot, you can actually observe the outliers with ease. Estimating the outliers, again, if you want to estimate the outliers, you can actually tend to have this standard deviation methods. For example, when you have standard deviation of 1, which is almost 68.2 here, and if you have the first, if you go to the second level, second standard deviation, you can see you can include more than 90%. And again, if you go for third standard deviation, it's going to be more than 97, 98%. Likewise, as you move further and further away, almost all your content is included, the distribution is filled in. So you can easily identify if there is one outlier somewhere very far from the center. Yes, that's one of the examples on estimating the outliers. Working with outliers, you can either do retention or exclusion. So you can see that if there is an outlier, is this outlier important to your domain? Do you want to retain this value? At times the robust informations can reveal that the outliers are of important, and naturally these outliers might occur, and you have to make sure that you include those outliers. But in those cases, if you don't include the outliers, your final results may be completely wrong. We will be discussing about one of those features in one of our lectures, where one of the space disaster has happened because people did not take into account certain outliers in it, data points which are in the outliers. Exclusion or deletion is another way. Sometimes we can actually delete or exclude the outliers based on, again, the domain. In your domain, if suppose you know that, for example, if you want measuring the temperature of a person, just as we have seen, the temperature ranges between, say, around 36 to say 37 degrees Celsius, and suddenly you get like 175 degrees Celsius, which is not going to happen, and it is obviously an outlier. It cannot be included. One possible thing is that maybe we have measured it wrongly. Yeah, so at times we can delete or exclude this data based on the domain that you are working in. So that's what we have seen today. We saw the importance of missing values, how these missing values can add a bias to your results, and we also talked about how these missing data can be imputed, or in other words, how we can actually handle this missing data. And finally, we talked about the outliers and its significance and ways to handle some of their outliers. Yes, these two are of prime importance, because at times we tend to exclude or delete the informations if they are an outlier, and at times we would tend to again ignore informations if there is a missing values. So we should make a wise decision based on your domain knowledge. You can make sure that whether you need to delete an outlier or you need to just ignore a missing value. So that's it for our discussion for today's lecture, and we are going to discuss about more information about the data itself, like what is a data and what are the structured and unstructured data, basically some data analysis part. That is in for our next lecture. Until then, goodbye.